Hello friend, my name is Aditya Kumar and today we will discuss class 9th CBSE board. It's a chemistry that is matter in around surrounding, matter in our surrounding. One this part we will discuss here. So let's see what is a matter. The question arises in this topic, what is a matter? So anything that occupy space and has their masses is called matter. So definition of matter is that anything that occupy space and has their masses is called matter. So exists in three physical state. It's a solid, liquid, gas. So matter are categorized by the basis of physical state. It's a solid, liquid, gas. Okay. Then classification of matter. So classified matter are classified by three state. You can see in the first part, we will see what that is, it's the physical state and physical state is the solid, liquid, gas, and by composition, it's the element, compound, and mixture. So matter are categorized on the basis of two part, physical state and composition. On the basis of physical state, they are in the three part. What? They are in three part. What is that? Anything we can see. Uh, so it's a solid, liquid, and gas. And by composition, element, compound, and mixture. So they are divided in this part. Okay. Then characteristics of the particle of matter. So we have four characteristics of particle of matter. That is, they have a space between them. So particle of matter have a space between them. Second, they are constantly moving. So particle of matter are constantly moving in the container, or you can say whatever container they are living, they are moving constantly and they attract each other. They have a very strong bond of attraction. They have a very strong force of attraction in solid, then liquid, and then gas. So they have different force of attraction inside the particle of the matter, and they are very small in size. So particle of matter are very small. Okay. So state of matter. State of matter in first one is a solid. So solid have a fixed shape and volume and negligible compressibility. We cannot compress them. So they have a negligible compressibility. We cannot compress them, and their shape and volume are fixed. But in liquid, no fixed shape but fixed volume. Their volume are fixed, but they have no shapes. Whatever container they are put, they take their shapes. Okay, so fixed volume. Liquid has fixed volume, you can see, and gas has no fixed shape or volume, highly compressible. We can compress gas, and we can put it in the cylinder form or in a pipe form. We can convert them. Okay, so change of state of matter, melting point. Conversion of solid to liquid is called melting, and the temperature at which it start melting, that is called melting point, and the process is called melting. Freezing, conversion of liquid to solid is called freezing, and the freezing point is the point temperature at which liquid is started to convert into solid, that is called freezing point. Then we have vaporization. When a liquid is started to convert into gas, that is called vaporization, or you can say boiling. Okay, so boiling is the process in which a liquid converted into gas, and boiling point is the temperature at which it is started to convert into liquid to gas. Then we have a condensation. Condensation is the process in which a gas is converted into what? A gas is converted into liquid. Then sublimation. Sublimation is the conversion of solid into gas without changing in liquid. It will not convert into liquid. Solid to liquid. Generally, what happens? It's converted into solid to liquid, then liquid to gas. So it directly converted from liquid to solid. In this part, they are convert, and then gas to solid. Okay. So example of this is a camphor, a naphthalene ball, solid carbon dioxide. So they are the sublime substance, and those substance which goes sublimation process, they are called sublime substance. Okay, I hope you understood this part. Let's see the another part, that is latent heat. The heat used without temperature change during the state change. During the state change, the heat used without changing the temperature, like latent heat of fusion, is 3.34 into 10 to the power 5 joule per kg ice to water. When a temperature, the heat required to convert ice to water without changing the temperature is called latent heat. Then we have a latent heat of vaporization, that is 22.5 into 10 to the power 5 joule per kg when water convert into joule. So it will not going to rise the temperature, but when we that heat is required to convert all the water into steam. So that temperature is called latent heat. I hope you understood these topics. Let's see next one. Evaporation. Evaporation is the surface phenomenon, not boiling. So evaporation and boiling, they are the two quantities. So evaporation is the surface phenomena, while boiling is a whole phenomena that happen in whole container. But evaporation happen in surface phenomena. Factor affecting the rates. What are the rates that affecting the evaporation? Like temperature. When temperature increase, evaporation is also increases. Then surface area. When surface area is increasing, evaporation is also increases. Okay. Then wind speed also saying arrow up, means when wind speed is increasing, evaporation will be also increase. And then for humidity, you can see when humidity is increases, evaporation is decreases. It's a downside. And pressure is also, when pressure is decreases, evaporation is increases. Okay. When pressure is increases, evaporation is decreases. So they have inverse proportion, but these three R's are direct proportions. You can say one thing is increasing, second thing is also increasing. Evaporation in daily life. Cooling in earthen pots. Earthen pots are cooled due to evaporation, and sweating cools the body. When we sweat, it cool down our body. So they are the daily life. And drying up the wet clothes. Drying up the wet cloth is also a evaporation in our daily life. Then salt extraction from seawater. So extraction of the salt, when seawater is evaporated, only salt are extracted from those part. Okay. In text question examples like why does hot food smell more than cold food? Because hot foods have more diffusion. Their particles are moving fast here and there, so they spread throughout the rooms and they goes away very long distance due to high kinetic energy of the particle of the hot foods. So they smell more than the cold food because faster diffusion of hot food particles. Why does ice cool better than the water at the same temperature? Because ice absorbs latent heat during the melting. During the melting, they absorbs more energy in the form of latent heat. That's why ice absorbs latent heat during the melting. That's why ice cool better than water at the same temperature. Important term like kinetic energy. The energy of the moving particle is known as kinetic energy. Then we have rigidity, fixed shape and volume. That is called rigid, solid, fixed shape and volume. Fluidity, ability to flow, like gas and liquid and gas are fluid. Diffusion, mixing of particle is called diffusion. So these are the some basic terms. Diagram of change of state like solid, liquid, gas. So solid to liquid, that is what? It's a melting. Liquid to gas, that is evaporation. Then liquid to solid is what? It's solidification. Then liquid to gas is what's boiling, and gas to liquid, that is condensation. And gas to direct solid, it's a deposition. Or solid to gas direct, it is a sublimation process. Sublimation is solid to gas, you can say. Okay. I hope you like this. And the summary part of this chapter is matter is made up of particle, and particle behave differently in states. Change in state due to the temperature and pressure, and latent is the key in the state change. So these are the some key particles we have used. If you like, please subscribe and follow my channel. Thank you so much, guys. Have a great day.